we are getting predict some value. This is the response. Of course, feature definitely multiply with some weight parameter. Okay, but even after multiplying with weight parameter, we are getting some kind of an output. That is the response vector. And if I am talking about some situations, for example, temperature and humidity, these are the two features of any somehow you can say the normal climate day, and alone you can say that the humidity does not make any sense, temperature does not make any sense. They are related, or you can say they are only window does not make any sense if there is a no room. If there is a no room, only door does not make any sense. Are you getting my point? Yes, there is a room, then you can say the benchmark thing is there. You are talking about some houses, then you can say the window, doors like it. So if we are talking about the climate, then of course humidity, temperature, these things predict about the climate changes. So none of the features irrelevant, especially in the Bayes theorem. Remember, it's very much important. In the Bayes theorem, this is the Bayes theorem. These are interrelated. Features are interrelated. So of course, contribution, window, door. This is the feature. Are talking about the window. It's equally important as well as the number of doors. So you observe this kind of a formula notions in the textbook, and if I make it very simple, because we studied in our course in the terms of y predicted value and x in terms of a feature. Let me explain this way. This is similar. Yes. Nothing changed. So if you are writing this here, if this one at the first place product, it doesn't matter, 3 into 2 or 2 into 3 doesn't matter. So be careful, don't be disturbed by this. So here y is our predicted output somehow depending upon the features. X represent the features, and of course it's not only the one feature, it's x represents talking about the number of the different features. So number of the different features. Let me explain this formula in terms of situation. This one first is the output yield. How often happen given that x happen. So I'm talking about the y output. If I'm talking about a house, if of course the number of the features, door, kitchens, rooms will of course. So how likely output? Then if I'm talking about the doors, rooms, windows, then it will be considered as a shop or some house. Of course there is some kind of a kitchen, depending how often, usually it is said like house, if there is a kitchen, some maybe use it as a store, or some maybe can use it as a shop, but usually, oftenly people know the building which is having a house, a kitchen, a room, washroom, so like a house, Yes, sir. So similarly, X features, if I am talking about a house, different features, like kitchen, like the number of rooms, like these features usually will happen over there. So this one, if you are talking about the for given feature in the set, I'm talking about the price of a house, how often X happens, given that Y happens. If I'm talking about the 2 crore rupees, then of course in this 2 crore rupees, they will not say only the single room, they will provide multiple features of the good decorated architecture house. Yes. So this is the thing. So my children, this formula a moment ago, X is dependent, the different elements are dependent. So window is depending upon the room. Window alone does not make any sense. So of course the size, number of the features, maybe number of doors, windows, fans, other things, these are the n features can be there in one room. So X represents the too many elements kind of a vector. And similarly, the too many features in some house, x1, x2, x3, xn. These are n represent size multiple 100 features, 10 features, 5 features, like so. So in situation assumption, this one is the I was talking about a moment ago. This was the Bayes theorem. Don't be confused with the naive Bayes. Naive Bayes is totally different. In this, features are independent. Features are independent. For example, on the roadside, someone is selling the only one window, no need of the door. Just he is selling a window. So he will talk. He will say that this window can be used inside of a house, but he is not talking about the price of a house. He will talk only about the price of the window, that particular window. So my children, in the main difference between the naive Bayes and the Bayes theorem, features are dependent upon one another, but in the naive Bayes, features are independent.
Sir, any example, sir, for this, sir?
Yeah.
Sir, any example, sir, practical example for naive Bayes?
Yeah, if I'm talking about some temperature, I do not relate this temperature with some climate or nothing else, for example. Yeah, it can be different. It does not need any humidity level of that particular day. I'm saying that the boiling water inside of a house, it does not associate with the humidity of that particular. Actually, this is a particular thing, like a window, particular window. It's selling of the window, sale of the window does not make. Even someone can buy a lot of bulk of the windows in order to store these in order to business purpose. It does not. You cannot follow the naive Bayes. Is it okay? Somehow you think you should go to in its detail by yourself. Right now in our AI course we focus on the Bayes theorem, simple Bayes theorem. So if I continue to the Bayes theorem, we can see that we want to play some game, for example nowadays FIFA, or you want to play outside, but you observe the outside outlook that it's rainy or it's overcast, some clouds are somehow sunny or whatsoever. This is the first column, represents outlook, and the second column represents the temperature. If it's very hot, it's very cold, or it's mild, or like things. Are you getting my point? The temperature outside. So now high, the situation is playing very good high, it's high moment. Our feeling to play very high, or we are not in a mood to play. This is not the so false. So if we should play, this is a holiday or something like the false. This is not a playing day. You can say that at the Juma prayer time usually we do not play. So the situation like this. So at the play, last is the outer one. You predict in the hill by considering these are the features. These are the features mingled up. Depending upon one another. So in all the situations, so you can say no, yes, like thing. This is the situation. So features are, my children, remember please, features kind of outlook, temperature, humidity, and windy environment kind of a thing are kind of a features. And response vector contains the value of class variables, are predicted somehow. This is the output, the play. Play is some kind of a class variable, or you are predicting some kind of output. Here, in this features, you remember the notions which can be used to represent the features X. X, X1, X2, X3, X4, so these are the features mainly. So output prediction in form of a classification, yes or no, why, is it clear please until here? Any question please? Thank you. So basically what we are classifying, we are determining the probability for playing or not playing by considering the features. A moment ago I described the features, mainly, thank you so much, so I don't need to explain it again. So now different situation, you can construct a truth table for this, because outlook, temperature, humidity, wind, and then you will finalize the play. Are you getting my point? By considering the truth table, situations like this, you can get it. It's very simple. If you say that how many times, for example here in this, you need count sunny, like you need to make a truth table for this. How many times sunny, how many times rainy. You can construct a truth table for this, and you will get the different variations of it. So this is the final probability why yes or no in the form of classification. Let me explain it a little bit more in form of the formulae. See, this one is the probability for determining play yes or no. Depending upon the various number of features, you will see this kind of notion in the textbook. And of course, first feature For example, if the sunny, our outlook is x1, okay, for the given chance, play or not. Then second, rainy, play or not. Then good mood, play or not. Okay, so the situation, well, so you can say finally the play, okay, this is the kind of product. Here, all in the denominator, there is a product of all the features. Because all the features are, you can say, playing their role of contribution out of, depending all the features, we are determining or we are classifying something in it. So this is the probability first, okay, with first feature, second feature, third feature. So this one is the separate thing. You are finally classifying, okay, probability of playing or not playing, yes or no. So here, this notion is using for the product purpose. All the features, okay, in terms of classification, depending situation, I to n, so first feature to n number of features. So this represents this notion used for product in probability. Once you are okay in the neural network, you will apply logarithm on it. Then this product will be. If you are applying the logarithm, then product will change into the summation. Okay, then of course basically you are sum up all the events. Okay, sum up all the values then. So in this way you can determine. Okay, I will here until here it is clear. Please little bit. Just yeah, this is not a pi. Tell me, okay, tell me then. This is a product. This is a product. If this use this sign. This one pi. This one product. Product. These are the probabilities, my children. So probabilities of each and every event with respect to playing or not playing. Okay, final output. Okay, because each thing is playing its role in the final determination. So you have this one. Okay, n number of probabilities with respect to this question. So you are, these are okay, multiply here, multiply. But in the true sense, once you are applying, you will make a model, what you will do, you will apply here log both sides. This log will change this product into the summation.
Yes, yes.
Okay, do you have mobile phones right now?
Yes, sir.
Go through, check out, write it, okay? Bayes theorem, concepts in the neural network, anywhere, okay? Check out some research article whatsoever, right now, please, right now. Bayes theorem applications, okay? Check out some research article, okay? It's better.
So Bayes theorem application in neural network?
And neural network, yes. Or AI, you can say Bayes theorem application in AI.